The HEM structure is used here to find the walking distance across the network from any given starting point. We can see the Euclidean distance indicated by a simple circle, here 400 meters, and in comparison, the portion of the network that is actually accessible within 400 meters depth. At the far right side of the canvas, this is formatted for a colored gradient preview. Returning to the metrics section, the overall length of paths reached in this catchment area is calculated at 5,955 and above a straightness measure that gives the ratio of actual depth versus the abstract Euclidean distance over all destination points. This set has an average ratio of 1.25, and the most meandering path is almost twice the distance at 1.91. Connect the index output from the Larson script to the point-to-point script's end index input, and this path will be drawn. Analyzing from a different starting vertex, we see the straightness ratio change, now over 1.45, and the least direct path has a value of 2.6, reflecting the more labyrinthine nature of this neighborhood. On the other hand, the reach has increased to 8,788 because the starting point is farther from the edge of the network and can expand in all directions. Increasing the depth limit to include the entire network gives another perspective. In this case, the reach will be the same for every point, but we get a new data point, called eccentricity, that gives the depth of the most distant point. This can be a surprising value, as in this case it is not the farthest by Euclidean distance, but one where the path turns back on itself. This script can also accept multiple starting point inputs. For example, all of the city's traditional gates, which can be used to find the nearest entrance and define catchment zones. Note that the color scale is connected to the depth limit slider.